Today's called the definition of a derivative, but it's not like I said, like a term that you look up in the dictionary. It's what is it's that thing in the box there. Okay. So the first thing I want to do is a derivative. What the heck is a derivative? A derivative, very simply, is a slope. Is a slope, right? What's a slope? Where did we hear slope before? You haven't heard slope in this class. We talk a little bit about slope in Math 3, but really it's a Math 1 and junior high topic. What is slope?
Rate of change.
Rate of change, right? Rate of change, right? You have that equation y2 minus y1 over x2 over x1, right? That's what slope is. Rise over run. You guys remember that? Y equals mx plus b. Those types of things, that's what slope is. Slope is a rate of change. How do we find it? We use y2 minus y1 over x2 minus x1. So that's what derivatives are. So one word to describe derivatives, they're slopes. Slope, right? It's a slope of what? A tangent line. Okay. So when I say tangent, I don't mean like sine, cosine, tangent. That's trig. When you're talking about lines, a tangent line, right? So let me give you an example. Let me draw a little picture here. If I had a circle or an oval, let me draw that one more time. Okay, so if I had a circle and I had a line, use a different color. That line could go right by the circle, right? It's not touching the circle at all, right? It can go right through the circle. It can go through the circle, right? When it goes through the circle, we call it a secant, right? It's slicing the circle, okay? The other option is a tangent. So what's the other, let me go back a few. So if we go through, that's one option, right? We do that, that's another option. What's the third option that the line can do with the circle? So a line can't go partially in because a line goes forever and ever and ever, right? So if it's going to cut through, it's going to cut through all the way. And if it's going to miss it, it's going to miss it all the way. There's a third option. What is that third option it could do?
Is it where it only meets at one point?
It ricochets. 1 point, right? Think of when you were a kid and you had a rock and you used to skip that rock across the water, right? You skip. It ricochets, right? It bounces off, it bounces off, it bounces off until it loses momentum, and then the water, then the rock went to the bottom of whatever it was, right? What's that?
Doesn't that make it three-dimensional if it's bouncing?
Yeah. Okay. So what does that look like in our class? It looks like this. So that blue line ricochets or touches the circle at 1 point. So we say the blue line is tangent to the circle at the red dot. That's what tangent means. It touches it at one spot. It kind of bounces off that thing.
So it's
Okay.
like a ball sitting on the ground.
So yeah, for this case, the red dot is where the blue line is tangent. So what will a derivative do? A derivative will tell us what the slope of the blue line is, right? What the slope is. What is the rise over run of that blue line? That's essentially what a derivative is. Okay? So let's look. I gave you an example here. So here's the function here. Let me highlight the function in green. So this is f of x here. Oops. That's f of x there. This guy, the red, does that go, what is the red's relationship with the green?
It's going through it.
It's going through it, right? It goes through it, right? kind of pierces it. That's a secant. So the red is a secant line. Okay? What would a tangent line look like? Well, let me draw that in blue. Tangent would look something like that. Right? It's tangent at, let me use a different color.
Wouldn't eventually they want the interconnect or
It would eventually, yeah, it would eventually. So let me get to that. It's tangent at the orange dot. Would it eventually run into this guy over here? That's where it would be a secant. So over here it's a tangent. Over here it would be a secant.
so line could be
It could be both, yeah.
so doesn't that make that bottom or never mind.
But when we're focusing on one point, we can say it's a tangent. This guy pierces right through. It doesn't bounce off, right? This guy bounces off at the orange, but then it's going to continue to go there, yeah. So let me draw another one. It touches in one spot, the orange. Now, is it slicing through as well? Yeah, but it's only touching at one spot as well. Okay? So that's kind of both. It can be both. Here's what we use derivatives for. I'll show you exactly what we use derivatives for. At that orange dot, at the first orange dot, is the function increasing or decreasing? Is the green increasing or decreasing? So we should have a positive tangent line. Does the blue line that touches it have a positive slope? Yeah. How about this guy here? Is the function increasing or decreasing here? Decreasing, right? So is the line that's tangent positive or negative slope? How do we know it's negative slope? It's going downhill. Anything going downhill, any line going downhill is going to have a negative slope. Any line going uphill is going to have a positive slope.
From the x-axis, like from 0 to like 100, like
We always start left to right. So you always start the left arrow and go to the right. Always left to right, yeah. That stuff, everything I just talked about right there, about slope, you guys learned in 7th and 8th grade, okay? So it's not the idea. So Mr. Lara and I were just having this discussion. In this class, it's never the calculus that's too hard. It's always the foundational stuff that you guys too hard. From 7th grade, 8th grade, Math 1, Math 2, Math 3, you guys were building a foundation. That's what you guys were doing. Here, in this class, we stop with the foundation. We're building a mansion. This class, we build a mansion. But if your foundation is not solid, it doesn't matter. I could have the greatest architects in the world who use the best materials there are. Mansion's going to crumble, right? So a lot of the stuff that we do today is going to be foundational, right? To build that. So when I say slope of a line, right? You guys have found slopes of line. When I say equation of a line, it's one of those three guys, right? Y equals mx plus b, the three forms, right? Standard form, slope intercept, and point slope. You guys did that in 7th and 8th grade, right? A little bit in Math 1 too, okay? So we're going to come back to a lot of those things, all right? So I don't want you to worry too much about, oh, derivatives, it's a new thing. Because if you're solid foundationally wise, you'll be fine, okay? You'll be fine, okay? So that's what a derivative is. How do we find a derivative? Well, this guy right here is the definition. It's the definition. It's what we're going to use today to find derivatives, okay? It's a limit problem. You guys just did a whole chapter. I'm grading tests right now, which are limits problems, right? So that's why I start with the definition, because it's a limit problem. So we're going to do limits today. That should sound familiar to you. You just had a whole section, or you just had a whole chapter of limits, okay? Before we get to that, there's some vocabulary. When I say a derivative, I mean a noun, a thing, right? A derivative is a thing. When I say differentiate, it's an action. It means you need to find the derivative. Differentiate means do actually calculate the derivative, okay? So that's the two words. You'll see differentiate and derivative a lot. That's the difference. One's an action, one's a noun, okay? You're gonna see a lot of symbols here. You're gonna see a lot of symbols. F prime. F prime means, here's the derivative. This is it right here. I'm showing it to you, okay? If you see the letters d over dx, it means you need to find the derivative. It's an action, okay? D dx is an action. Anything with a prime, a little tick mark there, means here's the answer. Here's the derivative. That's because you're going to see a lot of these guys this chapter. For the rest of the year, you're going to see a lot of these guys here. So knowing what each means is important. Anything with a prime, f prime of x, y prime means this is the derivative. dy over dx is the same thing. So these guys are all the same thing. Let me highlight them. So this guy, and this guy are all they all mean the same thing. Here's the derivative. Here's the derivative. This guy is an action. You need to find the derivative. You need to find it. I don't know it yet. You need to find it. So when you see d over dx, that means, what's the derivative? You got to tell me. If you see any of these primes or dy over dx, it means I already did it. Here's the answer. Okay? That's the difference between it. Okay? Now, why in calculus, we have a lot of symbols. We've got a lot of symbols. Why do we have so many symbols? Well, it's kind of an interesting story. It kind of goes back to the history of calculus. Does anyone know who invented calculus? Newton, right? Newton is the one who gets credit. He's the one who gets credit. But actually, there was another guy in Germany, because Newton was in England, right? He's the guy with the apple. Apple Falls, it's why Apple, the Apple company, Apple computers, Apple phones, iPhones, all that. It's why it's called Apple, because of Newton's apple that hit him in the head and he discovered gravity, right? How gravity works. Well, another thing he did was he created calculus. But at the same time, at the exact same time he was doing his discoveries in England, in Germany, there was a guy named Leibniz who was doing the exact same thing. They didn't know each other, they didn't talk to each other, but they were doing the same exact thing at the same exact time. So the reason we have so many symbols is because some are what we call Newtonian symbols, and some are called Leibniz symbols, Leibniz notation, okay? So anytime you see a dy over dx or d over dx, that's from Leibniz. He liked using those things. Anytime you see a prime, that's from Newton. Newton liked those things, or used those things. So that's why we use both. So it gets kind of confusing because there were two guys, and literally they didn't talk to each other. They didn't really know each other, but they were doing the same exact thing at the same time. The reason Newton gets the credit was because he's more well known. Everyone, if you know about, everyone's heard about the apple hitting Newton in the head, that story. So that is why Newton gets it. So there's a lot of, that's why we have a lot of notations. Okay, so keeping those straight is important. Okay? Okay, so here we go. Before we start a problem, remember the derivative is a tool. Okay? It's a tool to help us find the slope of those blue lines. So we use a derivative to find the rise over run for those blue lines. We said that the first blue line was positive and the second one was negative, right? Well, the derivative will actually help us find what the value is. Okay, so that's what a derivative is. Okay? Okay, so let's do example number 1. There's not many examples here because the definition isn't used a lot, but it is important. Okay? So find f prime of x. So find the derivative if, there's your function there, f of x equals x squared. So x squared is what we need to find the derivative of, right? Okay. So to do that, we're going to use the definition. So let's write down the definition. It's in the box above at the top of the page, but let's rewrite it. Okay, so the definition, so what we're trying to find is f prime of x, right? That's what we're trying to find. We're trying to figure out f prime of x. So it says to do that, you find the limit as h approaches 0. All right, why did I put x? It's supposed to be h. I'm just copying down what the box says. For f of x, x plus h minus f of x over x. So this guy here,
Is it H? Isn't the H on the bottom?
yeah, sorry. Yep, let me change that. Yep, sorry. There we go. Okay. That is the definition. That is the definition of a derivative or derivatives. Okay. We got to figure out how to use it though. So this is how we're going to use it. The first part is always going to stay. The limit as h approaches 0, that part's going to stay. The bottom is going to stay the same. It's just going to be h. The top is where we're going to use this guy here. Okay. I always start at the end. What is f of x for example number 1?
X squared?
So we're going to put x squared there. That's where I always start. Minus x squared. I always start there because that's just the original function. The original function is x squared.
Squared plus H then? Is that actually?
Well, no, I'm only here. Yeah, I'm only, so f of x is x squared. Okay, good there? Okay. Now, this is where it gets not a little tricky, but it does get a little, it does change a little bit. So, let me back up a little bit. So if I had something like this. Oops, I don't want that. So let's remember what those notations mean. When you see something that says f of 3, f of negative 6, what does that mean?
X equals that number.
So if I had something like this, how would I figure out what these two guys are?
Reverse operation.
No.
Use ABC.
What's the first thing I would do?
ABC. Plug it in.
Plug it in. That's what it is, right? It's just saying plug in when x is 3, what do you get? When x is negative 6, what do you get, right? You don't have to write this part down because you guys have done that. So you would literally go like this, right? And you would say, and you would just plug in 3 and 3, and then you would do the same thing here, right? Negative 6 and negative 6, and then you would do order of operations, right? You guys have done that. You guys have done that for a long time. All right. What does that mean?
X squared plus 8.
Plus equals X squared.
Ezekiel?
And the F function replace X with X plus 8.
There you go. Replace x with whatever's in the parentheses. So if this guy is in the parentheses, that's going to go in here. Just like we just did with 3 and negative 6, right? when 3 was inside parentheses, didn't I just plug in 3 everywhere x was?
So it doesn't matter.
When negative 6 was in parentheses, didn't I just plug in negative 6 for everywhere? It doesn't matter what's inside, you're just going to plug it in. So that guy is going to be there instead of x. So what did I do on the last one? Use parentheses, right? So use parentheses. I'm not going to plug in 6. I'm not going to plug in 3. What am I going to plug in? X plus h. X plus h. Just like you did. See, that's the thing. When I do this, you guys are solid. Oh, I just plug it in, right? But then when I change that to a variable, then things start happening, right? It's the same idea. It's the same idea because variables are numbers in math. Variables and numbers are the same thing in math. That's the kind of the tricky part. Okay? That's the first step. Plug it in. Second step, simplify. Let's multiply this guy. Because this guy means right? It means times itself, right? That's what squared means. So we got to simplify. So we can do, so depends how you are comfortable doing that. You could do FOIL, first times outer times inner times last, or you can do a multiplication table for these guys. So you can, multiplication table, x plus h over x plus h, and do it that way. However you're comfortable doing it, that's what we got to do for these two guys. Okay, I'll use FOIL since I think FOIL's easier. I do the multiplication table in Math 3 just to kind of be more visual, but in calculus I kind of do the FOIL method. It's the same method. Okay, first, outer, inner, last. That's what FOIL stands for. So the first, if I multiply the first two terms, that's x times x. If I multiply the outer terms, x times h, that's just positive x times h. Multiply the inner two terms, that's again x plus h. Or sorry, xh, x times h. Multiply the outer two terms, h squared. Okay.
Subtract square x.
And then I also have a subtract x squared here, good. Okay. Cancel those two out because it's x squared minus x squared. So let me bring back the limit. The limit as h approaches 0 for what I have left. What I have left is 2x plus h because these two guys are like terms. Right? I have two of them.
3 times h.
2xh plus h squared over h. What's the easiest way to find a limit? Plug it in. So plug it in, what do we get? Plug in 0 for h. You can do it mentally if you want. You don't have to write it down, or you can write it down. What would happen if we plugged in 0 for h?
You get 0
On top and on bottom, right? Because it's multiplication, right? If I plug in 0 here, 2 times 0, 2 times x times 0 is just 0. 0 squared is 0. 0 on the bottom is 0, so I'd get 0 over 0. Anytime you get 0 over 0 on a limit, you got to know I'm not done with working here. I'm not done with my job. Well, what do they all have in common?
h.
Factor out an h. So if I take away an h, that still leaves an h on top. Okay, h's cancel out because they're both monomials now. So now I get the limit as h approaches 0 for 2x plus h. Now plug in 0 for h. What do you get?
2x.
2x. Guess what we just did? We just found the derivative of x squared. This guy here, I forgot to write it, but essentially what we're doing is finding the derivative. So we can say the derivative of f is 2x. Now today we're using the definition. The definition takes a little bit of time. That's why there's only 4 problems on here. Okay? Next week, I'm going to show you a method of finding the derivative. That whole process here can be done in quick as it took me to snap my fingers. Okay? The reason I show you this method first is because it's important. And after I show you the easier methods, not the easier, the quicker methods, you're going to want to use the quicker methods, which is fine, but you got to know the definition. Okay, so before we go on to the next one, here's the thing. When do we stop you? So let me not ask a question. That here, that was the last time we used calculus. Were we done with the problem after that? Not even close, right? Not even close. But that was the last part of calculus. Everything after that was part of the foundational skills. All of this stuff here, was not calculus. Was not calculus. That was just factoring. You did it in Math 2 and Math 3, okay? Those are foundational skills, right? We didn't even have, the only time we did calculus was at the very beginning when we set it up, and at the very end when we plugged in 0, right? Those are the easiest parts of this problem, right? My mind, the hardest parts are here. Doing that, multiplying, FOIL, combining like terms, factoring. Those are things you guys have been doing in Math 2 and Math 3, okay? So when I say the foundation is the most important part, it's the most important part, okay? It is the most important part. Because people always say, you know, calculus is hard, calculus is hard. I'm like, calculus isn't the hard part. It's the foundation. It's the foundation that is hard. If you don't have the foundation skills, it can be a little hard. But if you know how to multiply binomial time a binomial, if you know how to combine like terms, if you know how to cancel out like terms, if you know how to factor, this process is not very hard, okay? So yeah, those foundational skills are the important ones, okay? Okay, so let's try the next one. Let's try the next one. Number 2. So number 2 is a different question. It says, find the slope of the tangent line. What is a derivative? Every time I ask you, I'm going to ask you this quite a bit this chapter. What is a derivative? No.
Where do you set the circle?
No.
It's the slope of the line tangent to
There
the
you go. Slope of the tangent line. Those are the 3 things I want you to say. Slope is the first thing of what? The tangent line, right? So now let's look at what I just underlined. Find the slope of the tangent line. So what do they want me to do? Find a derivative. This means find f prime of x. That's what it means. They use code a lot. Not really code, it's just different. They use different things to say find the derivative. They won't always say find the derivative like they did on number 1. This one they said find the slope of the tangent line. That means derivative. Okay, that means find the derivative. Okay? Again, that's one of the things. If you can see that, or if you understand that, it'll be a lot easier for you guys. Okay? Okay, so now we need to find f prime of x. So let's do the limit. the limit as h approaches 0, right? There's an h on bottom. There's a minus in between. What's f of x?
F of 5?
No. In this problem, what's f of x?
Negative 2x squared minus 7.
The function, yeah, the function. So the function is going to go here. I'm going to use parentheses. Since it's a trinomial, I'm going to use parentheses. It's not a binomial, or the last one was a monomial. This one's a trinomial, so I'm going to use parentheses because I'm subtracting the whole thing. Okay. Let me write the definition here. Okay. That's the definition. Okay, so we got the bottom, we got the right side. Now this fx plus h, what does f of x plus h mean to do? It's a command. What do? Plug in what? Not f of x. Plug in
X plus what plus h.
this guy everywhere I see an x. Everywhere I see an x, I'm going to plug that guy in. So it's going to look a little different. -2, parentheses, squared, -7, parentheses, plus 7. What do I put inside those parentheses? X plus h. X plus h. Calculus is done for right now. We'll come back to it in a second at the end. But right now, I gotta use my skills that I've learned, my foundational skills. So the first thing I gotta do is get rid of all of those parentheses. I don't want parentheses anymore. Okay? So, let me ask you a foundation question. Can I distribute the -2? No, not yet. Because of this exponent, right? There can't be an exponent there for me to distribute. Can I distribute the -7? Go for it. Can I distribute the -1? Go for it. So let's do that. Let's distribute what we can. So this -2, I can't distribute yet. I can distribute it, just not yet. I'll do it later. I'm going to distribute the -7 and the -1. So it becomes -7x minus 7h, and then plus 2x squared plus 7x minus 7. What's 7?
That's negative 7.
Oh, yeah, sorry, I forgot about that guy. I should have definitely put him in here. Wait, let me erase. Let me start over. Okay. -7x minus 7h, right? That's distributed. And then there's still a positive 7 in there that I don't need to distribute, but it's still important that it goes there, right? Now I need to distribute the -1, so that's going to be plus 2x squared plus 7x minus 7. A lot of 7s. Okay. Okay. I'm going to go real slow. So if I'm going too slow, just keep going. Just keep going. But I'm going to go real slow since it's a lot of foundational stuff here. Okay, and I don't want to go too fast on this. Okay? Okay. Now, I'm still not done with my parentheses. There's still parentheses there, but I'm unable to distribute the -2 in there. How do I get rid of that exponent? I'll give you a hint. I did it on the last problem. How did I get rid of that exponent on the last problem?
Foil.
Foil, right? I did this thing. That's what I'm going to do. Do I have to do it though? Because won't I get the same answer?
Yeah.
What did I get when I did that?
2.
I got x squared plus xh plus xh plus h squared. That's what I got. I mean, you can do it again if you want, but you're going to get the same answer. Okay. Negative 2 x plus h, x plus h, right? And then everything else. A lot of this stuff is going to cancel out. So it's not going to all stay up there, but it can't cancel out until I'm done with all the parentheses. Okay. So now I'm going to do the same exact thing I did on the last one. First, outer, inner, last. Negative 2 stays in the front. It's negative 2 times this guy. So I'm going to keep this stuff inside parentheses. X squared first plus 2xh plus h squared, right? Minus 7x minus 7h plus 7 plus x 2x squared plus 7x minus 7. Don't worry, a lot of this stuff will cancel out, but we have to carry it with us until it does.
And then you can distribute the negative 2.
Now I can distribute the negative 2 because there's no more
Exponent.
exponents. Okay, no more exponents. So now I can distribute the negative 2 to here, to there, to there. So I get the limit as h approaches 0. Negative 2x squared minus 4xh minus 2h squared, and then everything else that was up there to begin with, or from the last step. Finally done with all the parentheses. There's no more parentheses, which is good. Now I can start canceling things out, right? So let's look at the top.
Negative 2x.
I have a negative 2x squared, and then I also have a positive 2x squared, right? This guy, they're opposite, so they cancel out. Negative 7x and a positive 7x. And then plus 7, minus 7. So over half of it goes away, which is what we wanted. So let's see what we have left. Negative 4xh minus 2h squared minus 7h. Everything else went away. Still not ready for calculus yet.
They all have h.
They all have an h in common, right? There's a trinomial on top and a monomial on bottom. They all have at least one h. So I can factor out an h. So an h comes out, so that makes negative 4x minus 2h. That guy still keeps an h. And then negative 7 loses their h.
And then the h cancel out.
H's will cancel out, just like the last one.
Mr. Flores, I had a question.
Mhm.
Because the question asks us that x equals 5, so instead of 0, will we put in 5?
Yeah, we'll get to that. Yeah, that part's easy. That part, the x equals 5 part is super easy, but we just have to get to that part, yeah. So yeah. I'll show you what to do then. X approaches 0. What's left? Negative 4x minus 2h minus 7 over 1, right? I don't even need to write that 1, but I did anyway. Plug in 0. What are we plugging in 0 for? What letter? H. So when I plug in 0 for h, the only place it's going to go is in the middle term.
Just cancel out.
So that would cancel it out. So what's left?
Negative 4x.
You just found the derivative for f of x. That's the derivative. But like Seth was saying, that's not our answer, because they said they wanted us to find the slope of the tangent line. We'll go to the front page real quick. What was that important tool that I said? What was the part about the important tool? It's right in the middle of the first page.
The derivative is a tool.
The derivative is a tool to find the slope of the tangent line. I haven't found the slope yet, but this is the tool to find the slope. Okay? So let's bring it back up. Let's bring it back up here. So this
And we just plug in 5.
there you go. You're just going to plug in 5. Once you get the derivative, plug in 5 for x, and you're done.
Negative 27.
So negative 20 minus 7, yep, negative 27. So the derivative when x is equal to 5 is negative 27.
How does it look on the graph? Would it point that it touches?
So it would be extremely, so at when x equals 5 on this, it would be extremely negative. Like it would be almost vertical because it's going downhill so fast. Yeah, negative 27 slope means you're decreasing it really fast, right? So how do we read this? This is important. The derivative when x equals 5 is negative 27. So negative 27 means I go down 27. So imagine going down 27 and over how many?
5.
Nope. 1. 1, right? Because that's negative, the rise over run. So if I go down, so if I have a dot, and then I go down 27, like that's not even close to being 27. And then over 1, and then connect the dots. That's going down really fast because we start left and go right. It's almost vertical. That's what that means. Okay, that's what that means. Okay? All right. Like I said before, we did calculus at the very beginning. Once I started distributing, combining like terms, multiplying binomials, distributing, combining like terms, that wasn't calculus. That was not calculus. That was foundational stuff, right? When I say foundation, I mean 7th, 8th grade, Math 1, Math 2, Math 3, right? That's what, back in 7th and 8th grade, that's what your teacher was preparing you for. They knew this would eventually come. Some of you would get there, some of you wouldn't. So when they were talking about slope, that's what they were doing. They were preparing you for how to use it, okay?
So also on a graph, that would just be that, but like 5 times.
So yeah, that's a good idea. Well, let's do a graph. So on these problems, they're non-calculator, but let me show you what the graph would look like. That's a great idea. Let's see, Desmos. So we can't use a calculator on these, but for a visual, it's a good idea. So our function was f of x equals negative 2x squared minus 7x plus 7, right? Okay, so here's that guy. Let me back up a little bit. Now we wanted to know the slope of the tangent line at when x was what? 5, right? So that means we have to figure out where is the graph when x equals 5. Way down here, right? Right there. Right, because 5 is right here. So what we just did was, yeah, negative 70 something would be the y value. What we did was find the slope of the tangent line. So if I want to tangent that red line there, I can only touch it in one spot. It would have to look like that. It would glance it in one spot. What we just did was found the slope of my ruler. My ruler is going down very fast because it's going from left to right, it's going downhill extremely fast. So to find the derivative of this guy, I would have to go down 27 over 1. That's what we just did. Okay, that's a good way to check your answer. I know you can't use a calculator on tests, but it's a good way to check your answer. If it was going the opposite direction, like over here at negative 5, it would look like if they said when x is equal to negative 5, it would have looked like that. Yeah, which is be positive, extremely positive. What if they said when x was negative 2? Or is x negative 2?
Still positive?
Oh,
So it would be less positive, but it would be kind of like that.
yeah.
All right. At 1, it would be
Negative.
like that. Not as negative, but like that. Okay. All right. Okay, so we're not going to do the problem, but I want to take a look at the next one. I want to take a look at the next one because that's what we're going to do tomorrow. Okay. F of x is the function. Now we're going to find the equation of the tangent line. Equation of the tangent line. What do you need to use any of those guys? Any of those linear equations? What do we need? What do we always need? Starts with an S, so we've said the word a couple times today. Slope. We need a slope, right? So what we're going to do is we're going to do the exact same thing we did yesterday, or sorry, just earlier today. We're going to do this tomorrow. We're going to find the the derivative. Okay? Once we find the derivative, we're going to plug in 1. That'll give us the slope. And then we're going to use one of those guys to find the equation. Okay? That's what we're going to do. We'll do that tomorrow. We'll do example 3 and 4 tomorrow. If we finish early, I'll give you the practice, but I might wait till Monday to give you the practice just because I want you to do some more practice on this. So, yeah. So we'll do this tomorrow. We'll finish these 2 tomorrow.